come, let's go with the DC power transmission technology, that is introduction of HVDC transmission line. In this HVDC transmission line, we have a lot of growth of our nation requires. This growth requires increased consumption of energy, particularly electrical energy. This has led to increase in the generation and the transmission facilities to meet the increasing demand. So in USA countries, till the early 70s, the demand doubled every 10 years. In developing countries like India, the demand doubles every 7 years, which requires considerable investment in electrical power sector. Then the imperative of supplying energy at reasonable cost, coupled with the depleting reserves of non-renewable energy sources, has led to the establishment of remote generating station. That means environmental consideration, and sometimes the siting of power station at remote locations. Already I insist lots of times. Then a large hydro station are invariably at distance of hundreds of kilometers from the load center. The need to economize on costly investment in generation reserves, sharing of benefits in utilizing variability in generation mixers. That means load pattern HVDC given rise to interconnection of neighboring system and the development of large power grids. Then the remote generation and system interconnection lead to a search for efficient power transmission at increasing power levels. The increase in voltage level is not always feasible because the problems of AC transmission, particularly in long distance transmission, has led to the development of DC transmission. So, however, as generation and utilization of power remain at alternating current, the DC transmission requires conversion at two end from AC to DC and the sending end, then back to AC at the receiving end. This conversion is done converter station, rectifier station at the sending end and the inverter station at the receiving end. So beginning of that HVDC, we have a rectifier station. That end is called sending end. HVDC end is a receiving end. That end having inverter station. The converter are static, using high power thyristor connected in series to give the required voltage rating. Then the physical process of conversion is such that the same station can switch from rectifier to inverter by simple control act, and thus facilitating a power reversal. Even though the HVDC transmission made a modest beginning in 1984, sorry, 1954, when a 100-kilometer HVDC transmission line of 100 kilovolt 200 megawatt DC link was established between Swedish mainland and the island of Gotland. Until 1970s, the converter station utilized mercury arc valves for rectification. The successful use of thyristors for power control in industrial devices, it has to encourage its adaptation in HVDC converters by development of high power semiconductor devices. Then we must concentrate the comparison of AC and DC transmission. The AC transmission having some technical issues, that technical issues having some limitations also. So relative merits of the two modes of transmission, that means AC and DC, which need to be considered by a system planner or based on the factors. One is economic of transmission, another one is technical performance, third one is reliability. So those three beneficial factors allowable of major features of power system is the continuous expansion necessity by increasing power demand. So this particularly establishment of a particular line must be considered as a part of an over long term system planning. Then we have to reasonably consider as the economic plan. The economic plan says economics of power system or power transmission line says the cost of a transmission line includes the investment and operational cost. The investment includes cost of right of way, that means row, then transmission tower, conductor, insulator, and terminal equipment. Then the operational cost include mainly the cost of losses. Then it has some characteristics. The characteristics of insulators vary with the type of voltage applied. For simplicity, if it is assured that the insulator characteristics are similar for AC and DC and depend on the peak level of voltage applied with respect to ground, then it can be shown that for lines designed with the same insulation level, a DC line can carry as much power with lines designed with the same insulation level. Then the corona effects tend to be less significant on DC conductor. This is main disadvantage of AC. The one kind of advantages in DC. The corona effect tend to be less significant on DC conductor than for AC. And this also leads to the choice of economic size of conductor with DC transmission. Then the other factor that influence the line cost are the cost of compensation and terminal equipment. Then DC lines do not require compensation, but the terminal equipment costs are increased due to the presence of converter and filter. So the limitations of long distance AC transmission having some classifications. One is stability, reactive power and voltage regulation, line compensation, interconnection of AC system, ground impedance, current limit, voltage limit, short circuit current, power per conductor. So the bipolar DC line is more reliable than three conductor AC line. First, let us see the stability of AC conductor. Stability in the sense synchronous operation. Synchronous operation in the sense once the reactance of line of transformer can have to transmit from the sending end to receiving end. This much of transmission or transient occurs on the AC transmission line. That time the AC power can give to the most preferable losses. That losses are reactants. That reactants losses mean by X letter. So P is maximum when del equal to 90 and steady state stability limit is P minimum or P maximum equal to E1 in the E1 meant by sending in voltage, E2 meant by receiving in voltage. Both voltage having reactance power, so E1 E2 by X. Del is the angle of deflection of both sending end and receiving end voltage. So we had been put that angle deflection sine del. So sine del always 90 degree. So sorry, del is 90 degree, sine 90 equal to 1. So we can get P maximum equal to E1 E2 by X into 1. Finally 1 into anything, same value. So transient stability limit P maximum by 2 for long lines. X is determines the distance over which the natural load can be transmitted stability. DC lines having no stability. This X determines the distance over which the natural load can be transmitted stability. So in AC transmission line, HVAC transmission line having stability problem, in DC transmission line there is no stability problem. So we have to prefer HVDC for long distance transmission line. Then this is reactive power and voltage regulation. This voltage regulation meant voltage control in AC lines is complicated by the line charging and inductive voltage drops. The voltage profile in a AC line is relatively flat only for a fixed level of power transfer corresponding to surge impedance loading, that is SIL, SIL. Short form of SIL is surge impedance loading. So these are voltage control problems across the AC transmission line. So voltage profile varies with the line loading. Then the constant voltage at the line terminal, the midpoint voltage is reduced for line loading higher than SIL, surge impedance loading, and increased for loading less than surge impedance loading. These maintenance of constant voltage at the two end require reactive power control, sending end and receiving end. This from inductive to capacitive as the line loading is increased. Okay, the reactive power requirement increases with the increase in line length. Although the DC converter station requires reactive power related to the line loading, the line itself does not require reactive power. Then third one is line compensation. Yes, third one is line compensation. Line compensation reason mentioned earlier. AC line requires shunt and series compensation in long distance transmission, mainly to overcome the problem of line charging and stability limitations also. Then series capacitor and shunt inductor are used for this purpose. The increase in power transfer and voltage control is also possible through the use of static VR system, that means SVS. So the interconnection of AC system have some difficulties. That difficulties are mentioned here. Presence of large power oscillation tripping, increase in fault level, transmission of disturbances, asynchronous operation not possible. These all are difficulties under the interconnection of AC system. Okay. Next, we have to consider ground impedance. That means in AC transmission, the existence of ground, that means zero sequence current, cannot be permitted in steady state due to high magnitude of ground impedance, which will not only affect efficient transfer power, but also result in telephone interferences. The ground impedance is negligible for DC current. Then DC link can operate using one conductor with ground return, that means monopolar operation. Ground return is objectionably buried metallic structure. Buried metallic structure means pipes. Number of pipes console are combined together across this ground return object. These are present under the condition of subject to reduce the corrosion with DC current flow. So it is to be noted that even while operating the monopolar mode, the AC network feeding the DC converter station operates with balanced voltage and currents. A single pole operation having DC transmission system, it is possible for extended periods, while in AC transmission, single phase operation is not feasible for more than second. This ground impedance also some disadvantages. Already I gave more explanation for this ground impedance disadvantages. So slightly I have to insist two or some points here. That points are difficulty of breaking DC current, which result in high cost of DC breaker. One, and then second thing is complexity of control. Those two disadvantages are saying. Other than two disadvantages, it have more disadvantages. Already, I gave more information to the previous sections. Okay, then we have to clear reliability. Then reliability in the sense, yes, reliability is must known factor. The reliability of DC transmission system is quite good and comparably to that of AC system. An exhaustive record of existing HVDC links in the world is available from which the reliability statistics can be computed. The energy availability says energy availability in the sense 100 of 1 minus equivalent outage time by total time of percentage. Then the current limit to avoid heating of conductor and insulation throughout the overhead lines. Voltage limit is over voltage determine insulation level 2 or 3 times peak value of AC, 1.7 times the nominal value of DC. So both the values at maximum working voltage to avoid the limited losses and the radio interference. Then apart from these losses, we have to considerably reduced. Then third point is power for conductor per circuit. This power per conductor circuit is how many conductors are appeared across the transmission line. So we must know about the type of conductor. Uh, Already we know about in the conductor having two types, one is AC conductor and another one is DC conductor. The DC has only two conductor are possible to transmit the power, but AC conductor having three are possible to transmit their power level. So insulator required most preferable insulation for AC only because it has produced maximum losses, maximum different kind of losses. So AC conductor require insulator properties, more insulator properties. Then short circuit current, having interconnection increases while the short circuit loop, the interconnection may include their level. So interconnection is must during the short circuit current. Then the circuit breaker rating always necessity depends upon the circuit breaker. Come, let's go with the limitations of AC. This is economic of transmission. Already I gave more information for the economic of power transmission. Economic always reasonably considers the cost of transmission, investment cost, operational cost. Then DC transmission carries much power as three conductor AC line less row. So this power lossless only in the DC conductor. That means two conductors. DC conductor always having two conductors. This power loss always exhibit on DC conductor. This is a typical transmission line structure for 3000 to 4000 mega. This is a typical transmission line structure for approximately 2000 megawatt for DC and AC, HVDC and HVAC. This is also the effect of DC transmission line. In DC transmission line, no skin effect, otherwise reduces losses in DC. Then dielectric losses also reduces their losses in DC. Corona effect is reduces. Compensation losses is reduces on DC. But thermal equipment is costly because two type of converter and filter are replaced across the HVDC transmission line. So cost wise, it is huge. Then economic of power transmission system. This economic of power transmission system says very typical distance and cost comparison. Then advantages of DC transmission. It has some advantages. Greater power per conductor, simpler line construction, no charging current, no skin effect, synchronous operation is not needed, and hence stability is not a problem. These etc. These all are advantages and features are being in advantages of transmission DC transmission line. Then come, let's go with the HVDC transmission system. Very beginning of this class, I have to say in 1954 100 kV to 20 megawatt Swedish mainland and Iceland of Gotland mercury or valve till 1970s. These are thyristor ranges. Also, we seen the beginning of this class. Then HVDC system, short term of HVDC system, SC in the sense sending it, RE in the sense receiving it. So sending end is rectifier converter had been connected. Receiving end side, inverter had been connected. So both the converter, heart of the HVDC system operation. HVDC system operation without operate the help of rectifier and inverter. So both rectifier and inverter is must to transmit HVDC power. This is simple schematic DC line transformer ratio. Then the HVDC technology, it has some fundamental process conversion. AC to DC is rectifier and DC to AC is inverter. It has some typical classification: natural commutator converter, that mean NCC, voltage source converter, that mean VSC, then capacitor commutated converter, triple C. So these all are diagram meant by the HVDC, fundamental HVDC converter station diagram. Then come, let's go with the types of DC links. We have monopolar link, bipolar link, homopolar link. Monopolar link in the sense has only one conductor, usually of negative polarity, and uses ground or C return. Sometimes metallic return is also used, the monopolar link. Then bipolar link. Bipolar link, there is two conductor. That circuit diagram is given here. Bipolar in the sense having two conductor, one positive and another one is negative. Each may be double conductor in EHV lines. Each terminal has two sets of converter of identical rating in series on the DC side. Then homopolar has two or more conductors all having the same polarity and always operated with the ground or metallic return. This is homopolar links. Then component of an HVDC system. The HVDC system components, converter unit, then converter transformer, filter, reactive power source, smoothing reactor, DC switchgear. These all are component are connected across this HVDC transmission line. Come, let's go with first component, converter unit. On this converter unit says usually consists of two or three phase converter bridges connected in series to form a 12 pulse converter. This is converter unit. Okay, remaining things are already gave more theories, so no need to look further. Then converter transformer. The converter transformer can have different configuration: three phase, two winding, single phase, three winding, single phase, two winding. The valve side winding are connected in star delta. This is most enough. Then AC filter. There are three types of filters: AC filter, DC filter, high frequency filter. These three filters are very important across the HVDC system. Then reactive power source converter station require reactive power supply that is dependent on the active power loading about 50 to 60 percentage of the active power. This is enough. Smoothing reactor. A sufficiently large series reactor is used on DC side to smooth DC current and also for protection. Enough. Then DC switchgear. It is usually a modified AC equipment used to interrupt small DC current. That mean employed as disconnecting switches. This is DC switchgear. Okay, then um, planning, we have to look at the planning of HVDC transmission line. Hmm. Yes, modern trends in HVDC transmission line, multi-terminal planning. Yes, just a minute. These systems is said to be very carefully. Okay, next, planning for HVDC transmission line. The planning always consider cost, technical performance, reliability. These 3 point reasonably consider for planning of HVDC transmission system. Then modern trends are multi-terminal system, back-to-back transmission, and these connections said to be modern trends of HVDC transmission system. So these modern trends always keeping and going on present days. So modern trends voltage level is extra high voltage level apart from the HVDC, so we can follow extra high voltage level. Then um, just a minute, no need to look this because this is advanced version, and nowadays how the HVDC handled throughout the countries. And then we have some choices. That choices are to develop the HVDC into EHVDC. This is one step advanced level for throwing our nation. So this is introduction of HVDC. I hope you all are enjoyed and learn lot from this presentation. Thank you.